Alright guys, so this is 16.82 and it's two parts. The first part says, a rope of mass m and length L hangs from a ceiling. Show that the wave speed on the rope a distance y above the lower end is equal to v, or is v equals the square root of g times y. So I drew a picture. So this is our rope hanging from the ceiling. The entire length of the rope is L. And then this small segment of the rope is going to be y. So again, problem A says show the wave speed a distance y above the lower end. So this is that distance. All right, so what we want for part A, we want the wave speed v written in terms of square root gy. Basically what that means, we just want to show how we can get to this. So let's do that. So what we know that the mass per unit length of the rope is going to be the mass of the whole rope divided by length. We know force is equal to mass times acceleration, and then getting a bit more specific from there, we know the force of tension that's on the rope hanging is going to be equal to the mass of just this segment, because we're only looking at the force on the segment, times gravity, which is the acceleration. We know velocity is equal to the square root of force over the mass per unit length. And we also know the mass of segment y is equal to the mass per unit length times that distance y. So this times y. So starting from tension, we know that F tension equals the mass of the y segment times g. And we know that the mass of the y segment is equal to the mass per unit length times y. So we can write that. And then going from there, we can get v is equal to mu gy over mu. And we did that from swapping out the f or not swapping out. We did this using this. So solving for f and then replacing it. And then skipping some algebra, we get this. Of course, the mu's cancel, and we get gy. So that's part A done. And part B is another similar problem, saying it just wants to show how to get to the time for a pulse to travel through the length of the string. It wants us to show how to get to delta t is equal to 2 times the square root of L over G. So we're going to do this in a similar fashion. So this is what we want to get to again. We know that the give me 1 second. We know that the distance traveled by a wave is L is equal to v plus u over 2 times t. So then breaking that down with what we just did in part A, we know that v is equal to square root of g over L. So we can substitute that in for v plus u over 2 times t. In this case, u is 0. So this is effectively the answer, but then just to simplify further, you get t is equal to 2 times the square root of L over G, which is what we were asking the question. So as far as pitfalls, I would say really just being able to differentiate between the whole string versus treating the segment of the string. Just be careful in each part of the problem whether you're correctly using equations that represent the whole rope versus that segment of the rope. And as far as context, this is just to get you to understand how waves behave in a situation like this, and how you can manipulate waves to solve for an unknown variable. Or in this case, show how we can get to equations like this. All right, thanks for watching, guys.